Okay, it's 7:30, so let's get started. Today's lecture 5, or like the 5th week of lectures. And we'll be talking about containerization. So it's a buzzword, but we'll get into later about like what that actually means. Okay, so yeah, let's start off with some announcements as always. You have PA4 due this Wednesday, 3/29. As always, the late deadline is going to be on Saturday. Office hours are again posted on Ed and syllabus. Just as like a quick heads up for Wednesday office hours, they are updated on the syllabus now, but the room that they're in is Thurston 202, not Phillips 318, as it was before. So just if you plan on going to Wednesday office hours, just to make sure to be note of that. And also you should have probably received an email from somebody on the backend core staff telling you that they're like your mentor for this assignment. For like the next 3 assignments, we'll like try to like switch up some people so that if you want to, you can have a chance to like work more closely with someone on the core staff and get to meet them. So yeah, highly recommend you show up to like their particular office hours just to get to know them, so you can have like an easier time choosing a mentor for the hack challenge at the end of the course, in which you'll be kind of like selecting someone on the core staff to kind of help you with your project. Alrighty. So yeah, just a brief overview of what we covered so far in the course, right? So at this point, we've basically covered how to essentially build a functional backend app, right? We talked about those endpoints, routes. We've talked about, making our data actually kind of stay there every time we shut down and reopen our app again with databases. We've talked about making our data more complex with relational databases. If you remember, like the relationships that we talked about, one-to-one, one-to-many, many-to-many. And then finally, we talked about a way to, be able to query this data in a much easier format and in a format that's much more readable as code and familiar to us programmers through object-oriented programming, through abstractions and an object relational mapper, or an ORM, which is what we covered last week in lecture. So today, we won't actually be, doing more essential, I guess like into the actual nitty-gritty coding. We're not going to be like building our backend app anymore. We assume that we've already built our backend app on our own computer, but now we kind of want to, share our app with other people. So we're kind of like talk about how to, be able to like distribute this app with other people so that, everyone can use it and not just us playing it ourselves with like our little localhost computer and whatnot. Okay, so just for a quick review on what we talked about last week. So last week, we talked about ORMs, which again stands for object relational mappers, right? Essentially, we're turning that really, really messy SQL code into more readable code and to something that we're more familiar with in terms of like object-oriented programming. Remember that we represent entries in a database as an instance of an object, as opposed to just like rows that we query with SQL. We wrote classes. If you remember from our demo last week, it was for tasks and subclass. And these classes kind of represent sort of, or like kind of have a correlation with like a table in our database, right? And instead of like columns for the table, we define each like one of those columns to be like an attribute of that particular class. We're translating SQL into Python, as mentioned earlier, just to make it a lot easier for us to syntactically look at. Also kind of makes it easier on our end too, because now our IDE can kind of help us check for like syntax errors and other like formatting issues that raw SQL code, which was just entered in as a string, couldn't have done. And then finally, we have a lot of useful tools from SQL Alchemy, right? We had some like parameters that we could just enter into our like db.column in order to enforce these relations, whether that be like one-to-many. It was a lot easier creating our association table for our many-to-many relationship. And yeah, so these like parameters, so we just like, instead of actually having to like define it with a long SQL query, we now have these like flags that we can just set to like true or false to essentially make our data sort of manipulation and relationships a lot easier to build. Anyone questions on anything we went over last week? Cool. Wait, just as like a side note, something really cool with like SQL Alchemy too, like you don't have to, it's actually like pretty, I think, like scalable too, because like for one of my other classes, I'm also using SQL Alchemy to design like a backend, but this time I've connected it with like an actual database in terms of like MySQL, instead of just like this very like light version of a database that you're using with the files, a SQLite. So yeah, it's actually can be used to be built projects outside of this particular backend course. So yeah, definitely keep it in mind. Okay, so today we're going to talk about the deployment process. So how can we actually, start, kind of like packaging our code and allowing other people to use it as well, and not just us on our own local computer and, paying our own backend with Postman. So right now, all that code is hosted on our local computers. The way we've been actually like working our backend and using it is by testing it with Postman, right? We can simulate hitting that endpoint and getting a response from it. But deployment allows us to share that code with other people. So let's talk about essentially how that works. Before we get into like the actual process itself, we're going to define two particular environments that an app might sort of like live in. So we have a dev environment and a prod environment, right? So they're just like shortened versions of their longer words. So a dev environment is short for development, and a prod environment is short for production. The dev environment is, as the name suggests, just where all of like your development happens. You write code there, you test code there. You might have some messy things like print statements, debugging logs to kind of help ensure that your code is actually working the way you want it to work. In contrast, the prod environment is literally like the production quality, clean list, or like the cleanest state that your code can possibly be in, because it's essentially the code that like users or like clients or just like outside people kind of like interact with. So it has to be very, clean in terms of style, but also has to be error-free, which we help ensure by testing when our code is in the dev environment. Okay, so actually talking about the deployment process itself, there are 4 steps to it, but today we're just going to be covering the first 2. So first, we want to compress our code into a production environment. And then secondly, prepare that production environment to be run ready. And we'll kind of go a little bit deeper as we move to this presentation to kind of talk about what each of those things mean. But does anyone have any questions at the moment? Okay. Yeah. So the second 2 parts is what we're going to, or like number 3 and number 4 is what we're going to be covering next week in lecture. So that part is like the actual, I guess, like deployment itself, whereas the first 2 parts fall more under containerization. Yeah, so the question that we're going to be asking today is essentially like, how do we run our apps on other machines, right? So in production, we don't want to be running the apps off of our local machines. So usually we want to, actually run our apps on other machines, which are more likely going to be like servers, so that other people, so like other front ends can actually like interact with the app that we built. There's like a couple of reasons why we don't want to like run it on our local machines, right? First of all, like we don't want like, again, the app to just be like shutting down and like or starting back up again based on like our own usage of our local machine. Like if we like turn off our computer and start it back up again, does that mean like our app will just like die and come back up again? Probably won't be very, useful or beneficial for our clients. Secondly, for like security reasons as well, if you run it on your local machine, you might be like exposing your IP address, which is not something that you would want either. So yeah, been using the word environment a lot. So let's kind of jump a little bit deeper into, what actually composes of an environment. So the 4 things that compose of an environment is your operating system. So that would be like on your computers, maybe you're using like a Mac, a Windows, or the Linux operating system. The actual code itself. So this composes of things like your app.py, your db.py, for example. The libraries, which are like all the dependencies that you might have installed when you like pip install -r requirements.txt, essentially like the building blocks or like some tools you might need to actually ensure that your app is functioning properly. And then lastly, environment variables, which we'll dive a little bit deeper into. Yeah, any questions about just like the idea of environments in general? Okay, so yes, let's talk about environment variables. Okay, so the idea of environment variables is essentially like variables that contain information that you probably don't want just like anyone on the internet or like the public to kind of see. So some examples of these might be like username and password combinations, as well as like API keys. So you might be wondering like, oh, when will I like use a username and password combination in like my own app, right? Isn't that more something like someone might use to like log into my app? Well, a great example of this would be like the usage of like a database, right? So the database that you're using right now in doing your assignments is SQLite 3. SQLite 3 doesn't require a login. It kind of like stores information on that like on a file, right? But like in the project that I was kind of talking about earlier, from one of my other classes, we're using MySQL as a database. MySQL is like a lot more sort of like heavy load database than SQLite 3. It like probably does a lot more, but it's also a database that's actually like run on a server and doesn't just store your information on like a local file. So for that database, as well as like other relational databases that you might see out there, like PostgreSQL, you need some kind of like login to the database to like manage all of the tables that you have and kind of like see all the databases that you kind of like own. So it's that kind of login information that you might want in an environment variable, right? You don't just want anybody on the internet to be logging into your database. Another example of like API keys. For example, if you want to like do some testing, and for example, like a site might give you like a token, right? It might give you like some kind of secret key, and then that site might literally have the warning that's like, oh, this token is just for you. Don't share it with anyone else like on the internet. Keep it in a safe place. If you're going to use something like that in your code, very obviously, just like the website has instructed you, you probably wouldn't want to share that with everyone either, which is another thing that you might find very useful to put in an environment variable. So these environment variables are defined in a file, .env, in your local computer. And similarly, when you define some of these, when you like use these variables and define them in your local computer, if you were to actually deploy your app and into a server, you would want to create the same set of environment variables on the server. So what you kind of need to do is SSH into the server, which functionally just means like access the server and kind of use the server computer to create that same .env file in the local like file system on the server computer. So now that we see that like the environment variable is in your local computer and on the server computer, where is like the environment variable file not existing? Anyone have any ideas? Yeah. Yeah, so it's not on the internet. Like that's the one place that it's not on, which is exactly how I want it to be. Okay. So yeah, it wouldn't be on the internet also, just like for further context into like SSHing into like the server, like you can probably only like very limited people have access into be able to like take over the server computer, which means that not everybody will be able to access these environment variables. Okay, so here's like a visual example. This is exactly like the database login information I was talking about. So this is like the database is called Ithaca Transit. For example, a username and password, SN685, which is the net ID of Shingo over there. And then his password is super secure password. Thanks for revealing that. And yeah, so you in your env file, you would export these variables, database, username, and password that is set to these strings that we actually want to log into our database with. So then instead in our file, instead of actually just like, writing that and like telling everybody this is our login information, we just change it to the environment variable nodes so that it can be secret and accessed only by the people who, have access to them. Any general questions on environment variables? Okay. If not, let's move on. So yeah, here we see that the environment variable file is on your computer and also on the server, but not on the internet. Okay, so right now, so far in the class, we've kind of been doing like a very like small scale approach. All of the apps that you've been building have been, very lightweight and very like small in terms of scale and as well as functionality, right? You have Python 3, you've installed your dependencies with the requirements.txt, you run app.py, and then you ping some of your endpoints with Postgres. And this is very much okay for simple applications. But if we're talking about like a lot bigger of an application, what we're doing so far probably won't cut it anymore. For example, we might have a lot larger of a database that stores like a lot more information. There might be more custom package installations, and just generally more things that you have to install for your environment to kind of work. So setup becomes a lot more like cumbersome. So the question is kind of like, how can we automate this problem, right? Like, let's just think about like an app that has like multiple like functionalities. Maybe it has a lot of like different microservices, which is essentially like a part of the app that might like handle some particular function. Maybe you have like Python for like one part of your app, but that microservice is like built inside like a different language with like different dependencies. Just a lot to install, right? So we want a better way to kind of automate this process. The old way we would sort of do it is through virtualization. So essentially, we're going to be running like virtual machines. Does anybody like who has used a virtual machine before, possibly? Okay, yeah. So virtual machines are essentially like just running a computer on another computer. Like a very popular VM that you could probably think of is just like if you use like a MacBook, there's like boot camp for you to run like a Windows machine on your computer. And essentially, yeah, like essentially in the past, what would happen is that like a lot of these apps, each of these apps would kind of like have their own virtual machine to run on. And you might see how this is like definitely a little bit more cumbersome and sort of more heavy because there's going to be a lot of resources involved in running each of these virtual machines just to support each particular app, right? But it's probably not something we want. We want kind of like a more lightweight and a more efficient way to achieve the same goal. So the new way we do it is in a method called containerization. And this is kind of like the part where we sort of compress, or I guess, yeah, we're compressing our code and kind of preparing our production environment to be run ready. Okay, so first let's talk about compressing our code into a production environment. Okay, so the first thing that you want to do before like to actually compress your code into a run environment, I think this moved. Okay, yeah, is to clean up your code, right? As we kind of mentioned before, this is sort of the part where you're kind of allowing your code to be able to used by other people, which means that you only want to kind of give them the best version of your code. So make sure to kind of like clean up those print statements, those comments, make sure your code is sleek and actually functioning the way you kind of want it to function. But beyond actually just cleaning up your code, we'll use a software called Docker to actually help us kind of containerize the code. Essentially, what Docker does is that it kind of packages like our environment and like our code into a neat little container, which is like a standardized unit of software that can be like passed around to other machines and have it be run on those like other machines as well. We build our code into images and then we run them as containers. And the definitions of those we can talk about a little bit later as well. But essentially, you can think of an image as like a blueprint and a container as the thing that you would build out of the blueprint and you can actually like run your code with. Okay, so with Docker images, you would kind of like build your images from your source code. And essentially, it's where you kind of give setup instructions for the actual usage of your environment. There'll be something called a Docker file, which we'll be kind of demonstrating in like the demo later. But essentially in that Docker file, you kind of define how the image is essentially built. And then as opposed to like an image, which again is sort of like the blueprint, the container is what kind of comes out of the blueprint. And you will be able to run containers from your images. And you can think of containers as essentially like a live instance as your a live instance of your application. The container kind of contains all of like the bare minimum essentials you need to actually run your app, which is another reason that makes this process a lot more lightweight than like running the virtual machines as we've seen in the past. We can define running instructions for a container with like additional flags that you might enter in the terminal. And I guess like below are some commands that you can see to actually run these containers. But again, that'll be covered a little bit more in depth in the demo itself. So if we think about like running like Python app.py in the context of like after we've containerized our app, and maybe we're like running that container, then we'd be running Python app.py within the container itself and no longer sort of like in our local machine. And this is just going to be really important because it kind of, again, like lowers the amount of resources that we have to use and just makes things generally more modular and more efficient overall. Yeah, so just to reinforce the analogy again, We have images are to containers, as sort of classes are to objects. Like we kind of talked about before, classes being sort of the blueprint of an object, and you can make multiple instances of an object, right? In a similar way, you can like run multiple instances of a container based on the image that you build a container off of. So you have blueprints and houses, recipes and cakes, and essentially a set of like instructions, and then be able to like produce something out of that set of instructions. Okay, any questions on what we've covered so far? Okay, if not, let's kind of move on to the second part of, I guess, like the first two steps of the deployment process that we'll be covering. Oh, I guess like before we move on briefly, here's a visual example of essentially what it would look like now that you're using containerization as opposed to virtualization. So now instead of like each app having their own virtual machine that they have to run on, which again is really resource inefficient, now we sort of have a base layer of Docker kind of managing all of the running container instances of these apps. And again, since a container only contains like the bare minimum necessities for this app to run, we don't have to actually waste as many resources in running all of these apps that we can do also at the same time. Yeah, and I guess the benefits that I kind of just briefly covered in terms of like the with the visual in the previous slide before as well. But yes. Okay, next, to prepare production to be run ready. So now that we've actually, made these sort of like containers out of like the code and out of our code and out of the environment that we want to like kind of run our code in, the way we can actually share with other people is by also like putting it on the internet somehow. And in terms of, I guess like in terms of the containers, we use Docker Hub as opposed to, GitHub, which is the place that we would potentially, display our code to other people. So this is like a cloud-based service, kind of like GitHub is. It allows us to store our images in private and public repositories, very akin again to kind of what GitHub does. Okay, so kind of let's go over the general workflow for Docker. So first, we create our Docker file. Next, we build the image. So we kind of create the blueprint we need to actually make these containers to run, right? And then we push our images onto Docker Hub. Similar way, we kind of are able to like push our code onto GitHub. Note that we don't like build the container at this step, right? This step, we're still doing things like locally and kind of like publishing it on the internet. There's no reason we need to like actually like run a container here or build it here, given that like that's something we want to like share with other people, right? So all this stuff goes into Docker Hub. And then we have some other machine, which is probably going to be a server of some sort to actually, pull that image from Docker Hub. So essentially now our sort of like the instructions to run our code are sort of available on another machine. In this case, that other machine being the server. And now we can sort of run that live instance of our app. So kind of like run the container on the server machine. Does anybody have any questions about that general process? Yeah.
So like what's a Docker file?
Yeah, the Docker file is essentially like tells you like how to actually like build the image, and then the image tells you kind of how to build a container.
Okay.
Yeah. So yeah, any other questions? Okay. You might notice that like in this image, right? There's not just one whale that's being pulled by the server. There's like many, many whales. So yeah, why is that? We can talk about that a little bit. So essentially, like even though you have sort of like one container, or like you're able to like push up one, sort of like your pusher. Okay, you can push up an image and have like a single container. One app might actually contain like multiple containers, right? Kind of if you think about what that example I gave earlier, let's say you have like a really big app and like one part of it is like built in Python, you might have another microservice for it that uses like a different language or like a different framework. That thing might have like multiple containers that actually, compose of the entire app itself, which is kind of what the multitude of whales there kind of like stands for. And the way we are able to kind of like manage this like conglomeration of multiple containers is with something called Docker Compose. So essentially, it's a tool for being able to define and run your multi-container Docker apps. The way we kind of I guess like give instructions to how these multiple containers can kind of be like juggled and actually like used is with a Docker Compose YAML file to kind of define define again the instruction set. But for the context of this course, we'll only be kind of working with one container. So you don't have to worry about this too much, but essentially it's an option if you're to build like more complicated and larger scale apps in the future. Another like more concrete example that you can kind of think about is, let's say like Google Maps, for example, right? So you kind of like have a lot of things sort of going on in Google Maps. You actually have like the map itself, which potentially might be like one container, right? To like find the map and actually be able to like display it to the user. You have sort of like a service potentially for like finding the best paths to like a certain location and computing like, the car time, the like bicycle time, the walk time, maybe like the public transit time. So that thing might also be in like run inside, or that cursor might be contained in like another container, right? To kind of divide modularity in terms of the app. So that's something where potentially they might need Docker Compose to actually give an instruction set on terms of like how to juggle all of these things that are going on, and sort of like how these containers might fit in together. So yeah, again, here's sort of like a visual example of how this might work. So here you have like Python, you have PostgreSQL. So to actually juggle all of these things, you need Docker Compose to kind of manage all of the whales. So you kind of have an octopus that's like the boss of all of your whales. Any questions? Yeah.
Or would you have to separate them from like you had like React and one Python? Would you put that in the container? Or would you have to separate them?
Yeah, I guess like you can have like multiple in terms of like libraries and like dependencies in like one container. Even in like the apps that we've been building so far, right? You've installed like SQL Alchemy and like Flask, like those technologies being in one container. In terms of like things that are like literally built kind of like separately with different dependencies, and you want them to have that modularity to kind of take care of different things, like you kind of are able to like separate containers like that as well. In terms of like, I guess like just React and Python, you probably wouldn't be building like one service with both like React and Python just because they're not like frameworks for like the same, I guess, like language. So for those things, you potentially might want to separate them. Yeah. Any other questions? Okay. Cool. So just as a quick summary of what we've covered today. So first, to actually, I guess like get started with a containerization process, we define a Docker file to kind of specify the app's required environment to help build our Docker image. We then push that image to Docker Hub. And then potentially if you have like multiple containers or like multiple images that you would want to run, or like multiple images to like build containers off of, you kind of specify how that works in your Docker compose.yaml file. We haven't deployed anything yet. That's what we'll cover next week. So yeah. So lastly, just as like kind of like zooming out of this course, and just like a more general CS thing that people do in industry known as like DevOps, which is short for development operations. It's essentially kind of like the intersection of being able to actually build your software, as well as like testing and releasing the software. The goal of like many big tech companies is to be able to like build and ship their software very quickly, very efficiently. So they kind of have to have a seamless process for all of these things, which comes together in sort of like DevOps, which containerization kind of is a part of. So yeah, if this is something that you're interested in, it's something that you can explore further in industry as well. Yeah.
Why is that different than like something?
It kind of like, I think DevOps sort of like literally like focuses on like the I guess like the process that was like between like the actual development of the product itself and like kind of like it's like the shipping part of like the code process where you actually have to like ensure that it simultaneously ensure that it works, but also be able to like deploy it to like other people. Any other questions? Okay. If not, we'll be moving on to a quick demo for the rest of today.
All right, so I'll quickly get started on the demo. So basically, we're just going to go over the whole idea of containerization. Let me make this bigger. Just to explain what containerization is one more time, there's an analogy I like to use that Shungo taught me, which is you kind of think about images as being stored on Docker Hub, which is, let's say we want to think of it as like an app store where you can download apps, and that would be like downloading an image. Then when the app actually gets on your phone, that's like having an actual container, and then opening the app is like running that container. So the image is the same for everybody. Anyone can download it from Docker. You can then run it on your own, and it gets downloaded from like that one hub. And so that's kind of one way to think about it, where the images are just like a snapshot of some code, and then in the container is where you like put your env file stuff in, and that's where you actually get to run those like whatever those files were. And so that's like what we're going to be demoing here. To start, in order to make a Docker image, the first thing you need is a Docker file. And so the way to do this is you literally just make a file. And so in VS Code, there's this button right here to make a file, and it's literally called Docker file with a capital D and then no extensions. So we're going to be using PA4. So if you remember, we have all the old routes to run the files the same as it's always been. Right now, the server isn't up. So if I try to go on Postman to send it in a connection, will be refused because that server is not running. So now what we want to do is we actually want to configure this Docker file. The first thing we need to do is we want to specify what language we're using. So in this case, we're using Python. And so you start with from Python, and you give the version. So if you in your terminal, if you type in Python -- version, it'll give you the version you're currently using. So for me, you see down here, it's 3.10.9. So I'll just use that. The next thing we're going to do is we're going to want to create a directory in which we're putting everything that's in our PA4 folder right here. So this app.py, db.py, requirements.txt. So first thing we want to do is we're going to want to run mkdir, which is make directory. So this is the same as in a terminal. If you do like make directory temp2, you'll see like a second folder got created called temp2. This should be inside PA4. Okay. And so you want to make the directory, and we're going to call it like user/app. And this is just going to be our app that's like where we're going to be putting all our code. And then you want to change to actually move into this directory. And so to do that, there's the command work_dir. So change our working directory. And we just want to enter in this directory that we just made. So usr/app. Okay. So from here to actually copy what we have in our PA4 folder into what's going to be our Docker image, you have this command called copy. And then you need two elements after copy. And the first one is what you're copying, where you're copying from, and then where you're copying to. And so because our working directory is where we currently are, that's just going to be dot. And then because we changed our working directory here to be user/app, we want to just copy it to there. So we can just say copy dot and then another dot. So at this point, we now have all our code copied into this user/app. What do we want to do? Well, the next thing we want to do is we want to install our requirements. And so this is going to be the same thing where you have the command run to run a command. And then as always, as we've done for all the previous assignments, it's pip install -r requirements.txt. Does this make sense to everyone so far? Are there any questions about any of the commands we have? Okay. And then to finish it off, we need to actually run this. And so to do this, you have this command cmd, which is just another command for running something. And in this case, it's just Python app.py. So just to quickly explain the difference between run and command, they do the same thing, but you can only have one command in your Docker file. The idea is the command is your final command to actually run your app, whereas all your run commands are like where you actually spell it out. Run is everything to set up what you need in order for that final like command to run your app. Functionally, they do the same thing. From here, we're gonna save this Docker file. And also you can only have one command statement, but you can have multiple runs. So in this case, we have like run pip install. We also have like run make directory. But you can only have one command, so make sure to have that at the end, and that's the one that actually like starts your app. Okay, so then from here, we're gonna now go back into our terminal here, and I'm in this folder called temp, but I'm gonna cd into PA4. From here, we're gonna actually want to build our image, but because this is something that goes into, let's say, like production environments, we want to clean up all our code. What this means is we don't want to include this whole virtual environment folder. We don't need to include it because we have this requirements.txt, which specifies what needs to be in there. So there's no reason to include this massive folder of all this stuff. So we're going to delete this. And then from here, we can now just run our Docker build. And then Docker build doc because we're building from the folder we are currently in. So here it's going to take a minute to build. It's going through everything it needs to do to build this Docker image. We can wait for this to be done. And so after building our Docker image, what we're going to want to do is then create that container and run that container. So while this is finishing up, we can just, I guess we'll just wait. It should be quick. Does anyone have any questions at this point? Yeah.
Yeah, the copy command
Mhm.
is the first thought like your local current directory, and the second one is like the working directory of doctors, you say?
Yeah, exactly. So for our image, like I said, it was kind of just like a copy of what's on your file system at this point. And right now I seeded into PA4. So I'm in this folder right here. This is the directory I'm in locally, where I have app.py, db.py, Docker file, and requirements.txt. And I'm copying these 4 files into what will be user/app. Does that make sense? Okay. So at this point, this Docker container is now finished building, or this Docker image is finished building. From here, we can see all our images by running Docker image. Or sorry, it's Docker images. And we can see this is my PA5 from when I took the course a 1.5 years ago. And then this is the one I just built right now. So 21 seconds ago, I just built this image. If you see, we have no repository and no tag. So this is obviously an issue. We have the image ID so someone can find it, but not from Docker Hub because we need that repository and tag. And so what we can do is there's a command what the heck just happened? I'm sorry, guys. Okay. So what we can do is we can run Docker. Is this still recording? Oh. Okay. So yeah, the last command I ran was Docker images, and you can see all the last images you've built. But as I said, we have no repository or tag for this latest image. And so what we'd want to do is you want to run Docker build -t. And so -t allows you to specify the repository and tag. And so repository is going to be whatever your username is when you create your like Docker account. So if you see mine, I have MAW346. It's just my net ID. So I'll go back in here and I'll say MAW346. And then you'd put a colon with whatever you want the tag to be. Or this is still the repository. So you'd put like, in this case, like demo5, because that's what this is. And then if I just put the dot to build at my current directory, this image will be built. From here, I can say Docker images, And now I actually have a repository with the tag demo5. And then next we are going to try to build we're going to actually make this image into a container. And so to do this here, we're going to actually want to say Docker. So there's two commands to make a container. One is container create, and then there's container run, where run will also create that container for you. So you can just use Docker Docker create. So what we're going to do is we're going to say Docker Docker run is the one that does the creation and the running together. So we're going to say Docker run MW346 demo5. Oh, that's an issue. Is an old requirements file. Okay. So we're gonna have to now rebuild our image. Oh, and there's another. Okay. So now we have everything again. We're gonna rebuild this image, and then we're gonna have to do the run command. Okay. I think I actually messed up this tag thing. When we go to Docker images, okay. So we have this repository MAW346. What's actually supposed to happen is this demo5 is supposed to be in the repository part, and the tag is like a version number. So what happens is you do Docker build -t, and then you put the repository here. And so in this case, the repository is actually MAW346/demo5, and then you do the colon for what the tag is. And so the tag will default to latest. But if you want to specify a version number, like if we say v1, then we can build this, and then this is what like it would look like when we say Docker images. This is what it should look like. This line right here, where we have the repository includes your whatever your username is / whatever the project name is, and the tag is like a version number. And a lot of times you can just leave it as latest, and it'll always default to latest when you're trying to run stuff. So at this point, if we want to actually run this image here, this will create the container and run this. Okay, so this is like an issue with some of the requirements. I think I'm using like an old requirements file. I'll like upload a proper lecture where this looks, but basically this would end up running and like running our container, which is no different than if I had just done Python app.py. In which, okay, yeah, like the requirements is messed up here. But what ends up happening when I do this run command is that it creates this Docker container and it starts running that, but not in any interactive way. So we actually need to modify this command to look more like how it would, where we say Docker run, and then we actually specify that there's a certain port that we want to use, in which case we want to map our port locally to our port on Docker. So you have to say Docker run -p, and you put 8000:8000, because we want to map the 8000 on the Docker file to the 8000 on your local computer. And then you can say -it. And so -it specifies that it's an interactive mode, which allows you to control C when you want to actually quit out of this container, rather than if you don't have -it, you'd have to like manually close out the terminal and like make a new terminal. And so that's how you'd close out. So -it is really useful for just allowing you to command C. And then at the end, you'd put whatever the name of the image is. And then if you actually ran this, in most cases, this would work. Because the requirements is wrong here, this is causing issues. if this did run without any issues, your server would now be up. You wouldn't have to type in all the pip install requirements.txt, python app.py. It would all just happen from this one Docker run file because it's utilizing the Docker file that we created here that specifies how we want to set up our app. Okay. Does that make sense to everyone? Okay. With that, that's the end of the demo. I'll add on to the YouTube video that we post with like a working version of this that has like a proper requirements.txt file so that this actually runs. But if that's everything, we can move on to the Kahoot.